Hi, folks. This is Stan Forrester. We're in the middle of week two of module four. We're doing electromagnetic induction. From all the examples that we've come through, I'm sure everybody here now is aware of generators and their cousins, motors, which, there's this concepts are similar enough that you can actually design devices which are motor generators that, if driven from one end, will produce electricity, or if driven from another end, um, well, can act as a motor to another object. Okay, so, or even, let me go on. Let's say regenerative braking in some electric cars. They'll use the coils inside the drive motors when they're trying to brake, trying to slow down. They'll take that energy and convert that kinetic energy back into electrical energy and help recharge the car rather than just losing that to thermal energy. Okay, but there's also other things we can do. We can use them for sensors. For instance, one of the most interesting things I ever saw, it was a very simple experiment. The guy took a plastic tub and put electromagnetic sensors around the side, and literally these were just steel bolts that were drilled through the side. And they put like a little waterproof bushing on the thing, and then he just measured the electrical potential at each point. And then what he was doing was he was placing different objects inside this. The bucket itself had a conductive fluid in it, and then he placed different shaped objects in it. And he would send signals through each of the probes, each of the terminals, one at a time, and then measure the result on the other side. And then he was using AI to, well, not AI. This was way before AI. Using a neural net, which is the technology that AI is pretty well based on, to try to figure out what the shape of the object was. Okay, and so that was, and maybe that's old hat these days, but it was really interesting to me. Okay, other things, other applications that we can do, things that we've actually seen working and then applied. If you take, like some devices, you have these little pads, you can place your device down on the pad and it'll recharge it without a USB cable. I'm old fashioned. I use the USB cables, but some people do that. Okay. So those wireless charging pads, that energy's got to get transferred somehow. You have to have that electromagnetic coupling, and that's induction. Okay. Cooktops. There are some cooktops that they don't get warm, but the pan does, because you're running basically a radio signal, an alternating signal, and that interacts with the atoms in the pan and turning the pan itself into the heat source, because you have these eddy currents that are running around. The resistance inside the pan itself converts all that electrical energy to thermal energy, and you get to cook your food. How many of you like rock and roll music or electric guitars? I don't know. My current favorite is it's called Promontory. It's or Last of the Mohicans or the Gale. And I remember a gentleman playing that on the electric guitar, and so that's the little earworm going through my head right now. Credit cards, credit cards, or any kind of like institutional ID card. If you just take it, uh, put it up to a card reader, and it unlocks the door for you. We're talking electromagnetic induction. Okay. Just trying to make the point that we actually do apply some of this stuff. Okay. So if you have any questions, you'd like me to work a problem, anything of that sort, please drop me a message in the discussions, or send me an email if you'd prefer to do that privately. But yeah, let's go ahead and let's do this. And good luck on the next exam. The exam grades for the previous one are posted. Take advantage of those adaptive feedbacks. Uh, it's the adaptive feedback to earn points back. If you missed some points and you got a grade you didn't like, just go ahead and complete the adaptive feedback, and I'll try to get you some points back. Okay? Have a great week. Okay? Bye.